In this video, we're going to talk about hypothesis testing. We're going to talk about an introduction of what hypothesis testings are, and then we're going to go more specifically into the t-test. So first off, what's the point of doing hypothesis testings? Well, we often have claims especially in advertisement, where we're told that a population is better than another one, right? So we can have a manufacturer of insect repellent might claim that on average, their product is effective for longer than 6 hours. Well, this is a statistical hypothesis, right? And we want to decide whether the statistical hypothesis is reasonable or even justified. So in order to do that, we're going to conduct what's called hypothesis testings. And hypothesis testings, we have three key components. We're going to be formulating a hypothesis. We're going to collect data from a sample. So in your IB questions, this data will be given in the question. For your IAs, you're going to be collecting the data yourself. And then from there, we're going to do some mathematical calculations, and we're going to make a decision based on all of this. So the point of a hypothesis testing is really to claim if a certain data makes sense, right? So can we say that an insect repellent is efficient for longer than 6 hours, right? So these claims, we need to make sure that they're either realistic or not. In order to choose the stats test, we have three that we're going to be covering in this syllabus. So we have our chi-squared independence test, our chi-squared goodness of fit, and we have t-test. If ever you're wondering which test you need in order to evaluate your situation, this is a really useful video. It's especially useful to choose your stats test for an IB biology course, but it's really useful for our course as well. So I encourage you to watch this one. What we need to know for our course is that we have 3 steps we are always going to follow regardless of what test we choose. We're going to state the null and alternative hypothesis. So we're going to write this down on our test papers. We're going to calculate the p-value using our calculators. We're going to write down the p-value on our test papers. And then we're going to state our conclusion based on the comparisons between the calculated p-value and the significance level, which is something that's going to be given in the question. And we'll go more into detail about what this conclusion is. Now let's get started and talk about our t-test. Why would we want to use a t-test? Well, t-tests are the tests that we're using if we're comparing means of population. Now we could be doing a one sample t-test. In this case, we would be comparing one sample, so a certain data or specific statistics given about this sample, and we're comparing it to a mean. So for example of this is students in a computer class are tested to see if they are above the world average for 40 words per minute. So you see that the compared mean in this case is 40 words per minute. So it's given in the question, and we're going to be collecting data about this computer class. So that's a one sample. And then a two sample t-test, well, we're looking at 2 separate samples. We collect their data, or we're given information about both of these, and we compare them one with each other. So an example of that is 2 teachers are comparing the scores on the most recent test to determine which class has the stronger understanding of this topic. So the difference between these two is just if you have one sample that the data is given, or you have 2. So it's going to be a little bit different for the calculator use, but in both cases, our goal is comparing the means of our population. Okay, for a t-distribution, this is the t-distribution in red. So notice that it's very similar to a normal distribution. Now, in the IB, you do not need to know about this t-distribution. I just like to explain it if ever it helps for your general understanding. And that's also the reason why we call it a t-test in the first place, because we're using a t-distribution. The assumptions that we're going to be using is that your samples are independent from each other. So we need to make sure that both samples don't overlap. We don't have like the same individual in both. It follows something similar to a normal distribution. And we're going to always know what the variance is. Again, you don't really need to know these specifics. The most important thing in this slide is that the samples are independent from each other. Okay, at the beginning of this video, I said that we are going to be calculating a p-value. So the calculator will be giving us this p-value. Now, what does this p-value actually represent for us? It's going to be a probability given to us as a decimal. And this p-value represents the probability that our null hypothesis happening by chance. So in other words, it's the probability of the null hypothesis being true. So we're going to get a certain decimal value, and that's going to be the probability of a null hypothesis being true. When doing our hypothesis testings, we're always asking ourselves, is the probability of the null hypothesis occurring by chance or so unlikely that we reject our null hypothesis? If we reject our null hypothesis, well, by default, we're going to be accepting what's called the alternative hypothesis. So the smaller this p-value, the smaller the probability of the hypothesis being true, the more likely we are going to decide, well, this is too unlikely, therefore I'm rejecting this null hypothesis. I don't think that it makes reasonable sense to accept it. So we're just going to reject that. And how will we decide if this p-value is too small? Well, we're going to be comparing it to what's called a significance level, and this significance level will be given to you in each question. At this point in the video, if everything I'm talking about doesn't completely make sense, that's okay. We're going to do a lot of examples to try and understand all of this information. So we're going to start with talking about a one sample t-test. So that's when we have information just about one sample and we're comparing it to a mean. First thing we need to know is our hypotheses, right? So like I said, step one is always to state what the null and the alternative hypotheses are. For a t-test, here in this case, we're doing a one sample t-test, our null hypothesis is always going to be that our mean of our sample is equal to this value here. This value, we call it mu, so the mean. This value is going to be given in the question, okay? So the null hypothesis is always going to look something like this. This is going to be a number actually. And then we have three choices for alternative hypothesis. And this is going to be depending on the context of the question. You're either going to want to prove that your mean is bigger than the number, smaller than the number, or simply not equal to the number. And in the IB, they're going to refer to these as one-tailed or two-tailed. So if ever you see in a question like, oh, you want to do a t-test which is two-tailed, well, know that this is referring to the alternative hypothesis needing to be not equal to. And the reason that we call it one-tailed or two-tailed, you'll see in the next slide. Let's understand when we want to use bigger than, smaller than, or not equal to. Let's do a little example for null hypothesis. So if we have the average time for insect repellent to work is 6 hours. Okay, so in this case, we would be given some data about our sample of insect repellent, and our null hypothesis is that we want the mean of our sample to be equal to 6. Okay, well, in this question, we have 3 different cases. So either they could add information and say the manufacturer of this new insect repellent claims that on average, their product is superior in time. So superior in time meaning it takes more time, right? So in this case, we're going to want to prove that the mean is bigger than 6. Keyword being superior in time, right? If instead of having the case 1, we have the case 2, where the claim is that the product is inferior in time, smaller than, well, we're going to want to have an alternative hypothesis where it's going to be smaller than 6. And if instead we have a claim which is that the new product differs in time, well, this differs doesn't mean bigger than or smaller than, so we're going to use our two-tailed null alternative hypothesis. So we're going to have not equal to. So in this slide, you can see that the alternative hypothesis is solely dependent on the question itself. So keywords like differ, not equal to, smaller than, bigger than are going to be used for the alternative hypothesis. Okay, why do we call them one-tailed and two-tailed? It's simply because of where the p-value is being highlighted. So if it's smaller than, we're looking at shading only one part of the distribution, bigger than shading only one part. So these are one-tailed. And then two-tailed, we're looking at not equal to, right? Not equal to. So in this case, we're shading both sides. You don't need to understand these diagrams. So these diagrams are solely here to have a visual of our significance level or p-value. So understanding where it's shaded, again, you don't need to understand these diagrams. What you do need to remember is the conclusion. And this is the conclusion for every single one of our tests. So it's probably the most important thing to remember. We're going to reject the null hypothesis if our p-value, so this is from the calculator, is smaller than our significance level. This is the most important thing to remember for all of your hypothesis testings. Okay, let's go on and do some questions. For the next part, you're going to need your calculator. Okay, so here are the steps to do any one sample t-test. As you know, it's our typical tests. First, null and alternative hypothesis. So on your piece of paper, you're going to state what they are. Second, in your calculator, you're going to have two different options depending on what the question gives you. Either they give you data, or either give you statistics about your one sample. So where you're going to find this information in your calculator, we're going to go in Stats, and we're going to scroll twice to the right when we hit Test. The test that we're going to be doing is a t-test. So this t-test is for a one sample, the one that we're going to be looking at first. The other information we're going to want is eventually we're going to want to have a two sample t-test. So make sure that you choose the t and not the z because it's going to be different distributions. So we're going to choose the t-test. And at the very top, this is where you see you have either data or you have statistics. So the questions are going to be a little bit different of what to input on the calculator. And then once you are putting in the information in the calculator, it's going to give you a p-value. And then we're either going to reject it if the p-value is smaller than the significance. And our final step is always to put everything in context. So I want you to write a sentence about our questions. Okay, let's start. We have two examples. The first one, the manager of a restaurant chain goes to a seafood wholesaler and inspects a large catch of over 50,000 prawns. It is known that the population is normally distributed. We will buy the catch if the mean weight exceeds 55 grams per prawn. A random sample of 60 prawns is taken. The sample mean weight of this sample is 56.2 grams with a standard deviation of 4.2 grams. Conduct a one-tailed hypothesis test with significance level of 0.05 to determine whether the manager should purchase the catch. Okay, lots of information. What we need to understand for hypothesis testings is that even though we're looking at a smaller sample, our hypothesis testing are going to be applicable to the whole population. So that's why they're so important. So even though the fisherman or the restaurant chain manager only selected 60 prawns, we're going to use this sample to calculate if it's reasonable for him to buy the full population of the 50,000 prawns. Okay, so the first thing that we need to do for this question is we need to write down our null and our alternative hypothesis. So we are looking at 55 grams. If the mean weight exceeds 55 grams, then he's going to want to buy this. So 55 is this mean that we are going to be comparing our sample to. So the null hypothesis is that our mean is going to be equal to 55. All right, so let me show it. Oh, I didn't want to show everything. So the mean is going to be equal to 55. And then our alternative. Now, remember, we're going to want to see if they want to purchase this catch. They will only purchase this catch if the mean weight exceeds 55, exceeds, bigger than. So for this question, we're looking at an alternative, which is going to be bigger than. So we're going to have our null is always equal to, and our alternative is going to be bigger than. Notice these two numbers will always be the same for every single question we do. Okay, now that we have this information, let's put it into our calculators. So in our calculators, let me start from the beginning. We go in stats, test, t-test. We are not given data. We're not given the size of all the 60 prawns. Whew, thank you. We're given statistics about it. So I'm going to click on statistics. What am I given about my prawns? Well, I'm given the comparison mean. Our comparison mean is 55. I know that the mean of the sample, so let's go back. The sample mean is 56.2, so 56.2. And the standard deviation of the sample is 4.2, 4.2. N is the number of samples, so how many prawns do I have in my sample? I have 60. Next, I need to do the alternative hypothesis. So the alternative we said was bigger than. So I'm going to go on my calculator and insert bigger than. And then we are going to go ahead and calculate. You won't need to draw. You're always going to need to calculate. And now we have the important information. Out of all of this, the only value that's useful for us is the p-value here. So our p-value is 0.0154 if we round to 3 significant figures. Now remember, we want to compare this to our significance level. What's our significance level? 0.05. So our p-value in this case is smaller than our significance level. So on your sheet of paper, I want to see what the p-value is. I want to see the comparison to smaller than. If it's smaller than the significance level, we are rejecting our null hypothesis. If we're rejecting the null hypothesis, that means we're accepting the alternative. So it's either one or the other. If we're accepting the alternative, that means that we're saying that the mean is in fact bigger than 55. If the mean is bigger than 55, well, that's going to mean that we're going to want to purchase this catch because the mean is bigger than what we're comparing it to. Now let's look at our second example. The fat content in grams of 30 randomly selected pastries at a local bakery are recorded. For a mean fat content of pastries made at this bakery mu, conduct a two-tailed t-test where we have the null hypothesis is that it's equal to 16 grams, so 16 grams per pastry, and we're doing a 10% level of significance. Okay, so in this question, they're already giving us the alternative, the null hypothesis. And they're telling us that for the alternative hypothesis, we want to do a two-tailed t-test. Well, two-tailed t-test, we should know that that is the only possibility is not equal to. So not equal to 16. This is going to be the alternative hypothesis. Okay, so we have our null and alternative. Now we're ready to find our p-value. In this situation, we're going to go into our calculators. So we can go stats, test. We're still doing a t-test. This time we're given data, correct? So we're given data. Notice that when I click on data, we have a list which is being pulled up. So what we're going to need to do is we're going to need to insert all of these 30 numbers into our L1. So pause this video right now and insert your L1 for all these 3 data points. So once you've inserted everything in L1, we are ready to do our calculations. And oops, not the Z test. Let's do that again. So we're going to do a t-test. data. Now, what is the mean we're comparing it to? We're comparing it to 16. My list is an L1. I have a frequency of 1. I'm doing a two-tailed t-test, so not equal to. And then I go ahead and calculate it. And now I'm given a p-value. Wow, this is a huge p-value. So 69%. So in this case, since it's 69%, what are we going to do? Well, we need to compare it to the significance level, remembering that our significance level is 10%, so 0.1. So we're going to write down that our p-value is way bigger than our significance level. So this is in a situation where we're going to be accepting the null hypothesis. So since we're accepting the null hypothesis, then we cannot conclude that the mean fat is different than 16 grams. Right? So we're accepting the fact that it's equal to 16, therefore we cannot say that it's different than 16.